Hello everyone. Today we're wrapping up the notes from last week, where we're going to use the sum and difference formulas to establish and define and prove different identities. So we're going to start off with number 1. The cosine of pi minus theta is equal to the negative cosine of theta. So first things first, we're going to apply our sum and differences of cosines to this, such that the left side will become the cosine of pi times the cosine of theta, plus, because we're going to swap the sign for the sum and differences of cosine equation, the sine of pi times the sine of theta. We're saying that's going to equal negative cosine of theta. Well, at this point, we're going to plug in our values that we know from our unit circle or from our memory. The cosine of pi is negative 1. The cosine of theta is still the cosine of theta. I'm going to add to it the sine of pi, which is 0, times the sine of theta. We're going to say that's equal negative cosine of theta. Well, by multiplication, anything multiplied by 0 is simply 0. And negative 1 times the cosine of theta is simply negative cosine of theta. Is that equal to the negative cosine of theta? Yes. The negative cosine of theta plus 0 is equal to negative cosine of theta, using the sum and difference formula. Let's take a look at number 2. It looks a little bit more doozier, but that's fine. It's going to follow the same steps. We want to prove that the sine of 3 pi over 2 plus theta is equal to negative cosine of theta. So we're going to use our sine rules, or the sum and difference of sines, such that the sine of 3 pi over 2 times cosine of theta, plus, because we keep the same operator, the cosine of 3 pi over 2 times the sine of theta is equal to the negative cosine of theta. If we consult our unit circle, the sine of 3 pi over 2 is negative 1. The cosine of theta is still the cosine of theta. The cosine of 3 pi over 2, though, is 0 times the sine of theta. Is that equal to the negative cosine of theta? Well, over here on the left, negative 1 times the cosine of theta gives us negative cosine of theta. And then anything times 0 is 0, plus 0 equals negative cosine of theta. Well, we've got our negative cosine of theta is equal to our negative cosine of theta, making this a valid statement. 2 more problems. And they look crazy, but don't worry, they're not. We just have to follow our steps in our process. The sine of alpha plus beta plus the sine of alpha minus beta is equal to 2 sine of alpha times the cosine of beta. So we're going to do the sum and differences for this first part and the second part. I'll do this first part in red and the second part in blue, just to help you distinguish the different parts. So the sine of alpha plus beta means that we're going to do the sine of alpha times the cosine of beta, keep the same operator, plus the cosine of alpha times the sine of beta. We're going to add to that the sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. There's a little scrunch there at the end, but we have a positive cosine alpha sine beta and a negative cosine alpha sine beta. So those two are going to cancel out. Positive cancels out with negative. And that leaves us with sine A cosine beta and a sine alpha cosine beta. So it leaves us with two of those. So it leaves us with 2 sine alpha times the cosine of beta, which is exactly what we have there. One step, all done. Number 4, we want to prove that the cosine of alpha minus beta divided by the sine of alpha times the cosine of beta is equal to the cotangent of alpha plus the tangent of beta. All right, so once more, we're just going to apply our rules to this. The sum and difference of cosine for the numerator says that the cosine of alpha minus beta is going to be equal to the cosine of alpha times the cosine of beta plus, because we're going to swap the signs, the sine of alpha times the sine of beta. In our denominator, well, denominator stays as what's given there, the sine of alpha times the cosine of beta. Now we have a numerator that has an operator of addition over a denominator that doesn't have any operators, which means that we can expand this. We can break this up into 2 separate fractions, such that we have the cosine of alpha times the cosine of beta over sine of alpha times cosine beta, and some of you might be seeing where I'm going with this, plus my sine of alpha times the sine of beta over the sine of alpha times the cosine of beta. Now we look for things we can cancel out. Well, on this first one, on the left side, I've got the cosine of beta and the cosine of beta. And on the right side, I've got the sine of A and the sine of A. So this breaks down into the cosine of alpha over the sine of alpha plus the sine of beta over the cosine of beta. Well, if we recall from our quotient properties, cotangent is simply, let's see, different color, brown. Cotangent is the same as cosine over sine, and tangent is sine over cosine. So the cosine of A divided by the sine of A is the same as the cotangent of that alpha. The plus comes down. The sine of beta divided by the cosine of beta, well, that's the same as the tangent of beta. Look at that. Same thing. So a couple more steps, but that's fine. It's just application of the process. If you have questions, please let me know.